Hello, everyone. Good morning, afternoon, and evening. My name is 𝗏𝗧 𝗏𝗃𝗧, Community Program Manager at Databricks. I want to welcome all of you to today's MLflow Community Meetup. We are so excited to have you here. A big thank you to everyone joining us live, and a special shout out to our speakers, Yuki Watanabe from Databricks and Sandeep Raveesh from AWS. Wherever you're tuning in from today, YouTube, X, LinkedIn, you're part of the conversation. Feel free to drop a comment in the chat and let us know where you're tuning in from. We would love to say hello. Okay. A quick overview of today's agenda. We're going to cover just some simple ways to participate in the MLflow community. And our presentations, we have a jam-packed schedule. Yuki will kick things off with an MLflow 3 release recap and a preview of the official TypeScript SDK, sharing the latest features for GenAI, evaluation-driven development, and what's coming next for the platform. Then Sandeep from AWS will take us on a deep dive into managed MLflow services within the Sagemaker ecosystem, exploring how Sagemaker's managed MLflow enables scalable, secure, and integrated ML experimentation and deployment on AWS. So there are many ways to connect with fellow MLflow users, contribute to the project, and stay up to date. Just going to cover a few ways here, like joining our Slack, our MLflow user Slack. A lot of conversations, our latest release are posted there. Ask questions. You can also contribute on GitHub. Register for future events on Luma, like this community meetup, where we will also be hosting an upcoming MLflow office hours. Follow us on X and visit our newly updated website, mlflow.org. Also, before we turn things over to Yuki, I just wanted to say, after each presentation today, we will have a live Q&A with the speaker. So keep your questions coming in the chat, and we will be sure to answer them live. And with that, we'll pass it over to Yuki.
Databricks, and I'm a core maintainer of MLflow at full time. So today I'm gonna So today I'm gonna talk about two topics. The first is a recap of MLflow 3, and the second one is a TypeScript SDK, the preview of the incoming feature. So we released MLflow 3.0 stable version 2 weeks ago, and announced that in the Data and AI Summit, the largest data and AI conference in the world in San Francisco. So we kind of renewed the website, we redesigned our data architecture and added a lot of features for GenAI and MLOps. So I'll cover a bit of it and in this section. And after the announcement, we saw huge wave of reaction from the community, like the social media, like LinkedIn, Medium, blogs, or blah, blah. So yeah, which is great. And also we are seeing a lot of velocity in the feature requests and issues about the new features, such as tracing, prompt registry, and etc. So if you want to contribute to open source software ever, I think this is a very good chance to get started. So we are pretty looking forward to your contributions as well. And yeah, the release is packed with a lot of new features. So I cannot cover all the features in this short session. So I would like to focus on the one important aspect of it, which is evaluation. So there's an emerging term in the MLOps world, which is called evaluation-driven development, which is aiming to solve the biggest challenge in the GenAI development. So I'm going to cover new features and what MLflow 3 can help with this paradigm. Yeah. So the first question is like, why variation? So the short answer is quality. So based on the survey last year, the color is a bit, yeah, it's black, but anyway. So based on the survey, the number one blocker for organization to launch the GenAI app into production is actually quality. So many companies start LLM or GenAI project, but most of them actually cannot be productionized due to not being able to surpass the quality bar. But indeed, making sure your LLM or agent behaves properly and returning the high quality answer is quite challenging because LLM behavior is not deterministic in general, and they accept the free user input, which has a much larger freedom range compared to the numeric tensors we were dealing before. And so quality has many aspects, not only a simple metrics like accuracy, precision. So there are many different criteria need to be assessed before launching user-facing apps. Also, LLM-based application includes different building blocks such as foundation models, retrievers, tools. So when we update any of them, we need to make sure there's no regression and it actually improves the quality. So going back to the previous slide, so the one solution to this challenge is evaluation-driven development. So conceptually, it is similar to test-driven development in software world, where we trying to control the direction of the complex software by using tests as an anchor. So we write a test that represent our requirements, the expected behavior, and implement the software so that it meets that requirement. So evaluation-driven development is similar in terms that we use evaluation as a cornerstones. And there are 5 different periods in this process, as shown in the slide. So data collection, building, human feedback, and automatic evaluation, and monitoring. So we built MLflow 3 to provide a comprehensive support for each phase of this cycle and promote this practice to the industry. So everyone in the industry can build LLM GenAI apps with confidence and, more importantly, ship it to the production and actually gain the value from it. So let's take a look at each step. So for building phase, the main task to do in the building phase is actually coding your agent or your LLM apps, or maybe you can use the raw code tool as well, and casually iterate on it until you reach the point of, okay, so it works. And there are many great frameworks that makes it easy to get started on LLM development. But when it comes to more complex use case than tutorials, you always need to do some trial and error, doing some customization, and which is a bit tricky. So tracing really helps debugging errors and quality issues in this process. So when you auto-enable the tracing in your notebook or manually instrument your code, MLflow will display the trace in the notebook, which displays all the intermediate steps executed in the agent or LLM apps. For example, if you are using LangGraph, we will see a list of graph nodes, and also the intermediate actions like function calling inside a node, as shown in the picture. So yeah, you can debug errors from here, or you can see what data is actually passed in, what prompt is used, a lot of useful information for developing your agent. So yeah, this is cool, but this is still a 2.x feature, so nothing new. But in MLflow 3, we also covered the human feedback. So after building your agent, the next step is actually evaluating that, and most likely it's manually. Yeah, I'll cover the automatic evaluation later, but the human feedback is still very important. You cannot like truly determine the quality of your agent other than evaluating it with like manual inspection with deep domain knowledge. So since MLflow 3, we support tracking human feedback built in. So in other words, like we can track annotations. So on the right part of the trace UI, you can see this red box where assessment, which called assessment. So here you can see various feedbacks about like outcomes of the agent. For example, if the answer is correct or not, if it matches with the expected response, if the agent called the right set of tools, or if the retriever get a sufficient context, and etc. So these feedbacks are then persisted on traces with metadata such as who added that feedback, or what is the rationale of the feedback, or yeah. So since feedbacks are generated by not only by a single person typically, for example, there can be like multiple annotators to get consensus, or we might use automated uh, judges like LLMs. So it's very important to have that metadata there to keep track of how and why those feedbacks are generated. And moreover, you can also use it to store ground truths as shown in the below. So for example, expected response equal facts, which we can use for automatic evaluation in the next step. All right, so now we the manual evaluation, manual feedback tracking. But yeah, when you start iterating more and more and improving the agent with a lot of new models or new methods, human feedbacks quickly becomes a bottleneck. So that's where we should move to automatic evaluation. And MLflow 3 introduced a new evaluation suite that natively integrates with tracing and feedback tracking. So as you can see, we have a new API, MLflow.GenAI evaluate, where you can directly put those traces and with a lot of evaluation criteria, which we call scholars, and then MLflow automatically executes those scholars upon the traces and intelligently extract the data from traces such as retrieved context or tool called tools used in the execution. And it's also it runs like in parallel so that the version doesn't take so much time. And yeah, of course, you can use this API to evaluate the table data, just like we are doing today. And we also provide a lot of built-in scorers, including LLM as a judge. So, and you can also create LLM judge with custom prompts or custom guidelines, as shown in the bottom half of the code example. And those built-in scorers are very powerful, but you often also need a custom domain-specific metrics. So MLflow allows you to define such custom evaluation criteria just within a few lines of code. So as you can see, you just need to define a function that takes outputs, expectations, or inputs, and you can just declare it as scholar, then that becomes a scholar to MLflow. So inside this function, you have access to model inputs, outputs, traces, and ground truths, which gives you pretty much the flexibility to define almost all evaluation criteria for your model application. So for example, you can get the intermediate retrieval outputs from the trace to evaluate the retrieval quality. And with this, you can also plug in other great evaluation framework such as RAGAS, DeepChecks, 𝗵𝗏𝗃, Galileo in just a few lines of code in this example, and track the metrics, track the score in the MLflow. And once you execute the evaluation, you will see the result like this. So it shows the metrics computed by those scorers and its aggregation on the top. It's a bit small screen, but yeah, my bad. And to dig deep into what a particular response is good or bad, for example, in the fourth example, we have a correctness set evaluated as false. So in order to see the root cause, you can click the row and open the trace, and you can find the root cause from all the intermediate steps executed. For example, there might be a retriever span that doesn't return the correct sufficient context. So yeah, so far we covered the manual and auto variation. And once you gain the confidence from those offline evaluation, the next step is deploying the app. However, it is critical to have the monitoring system ready by deploying because offline evaluation does not guarantee that the app performs well in the real environment. Also, without monitoring setup, you will routes the best information to improve your app, which is the real user feedback. And yeah, MLflow Tracing is obviously a great tool for monitoring as well. So MLflow allows sending traces to different monitoring backends, such as of course, Databricks, Datadog, Grafana, New Relic, those important, like famous monitoring platform, I would say, but also the self-hosted tracking server as well. And since trace contains rich information about the execution, such as input-output errors, intermediate state, and latency, you can build whatever dashboard to monitor your application. For example, if you use Databricks, managed MLflow automatically creates a dashboard for operational metrics and quality metrics, just shown in this slide. So, and with a configured set of like a set of scores and sampling rate, ratio, and yeah. So this is pretty powerful capability that allows you to assess quality in a unified way between offline and the production environment, because yeah, you use the same Scholar implementation between the offline and online. So you won't have a drift, or you won't have a like mistakenly use different criteria in the monitoring. And moreover, combined with the human feedback tracking capability, which we covered before, you can also record users' feedback directly into the traces and show them in the dashboard. Also, you can use it for evaluation data creation. And I will show the simple example of this in the demo part later. All right, so after you have a monitoring set up, you get the real user traffic and feedbacks. So which is a great source of creating the data set. So yep. Yeah, MLflow 3 natively support dataset management. So you can easily convert real traffic into dataset using traces. So the trace in the monitor page have a button that allows you to create traces into a dataset. For example, you can create a dataset that contains a set of failure cases from the production system and run evaluation against dataset in your deployment pipeline to make sure your updated model doesn't hit the same mistake. So you can run that test and whenever you deploy a new model or a new chatbot, new apps. And yeah, those zero production failure is a great guardrail for you to not making the same mistake in the product. So this data collection step from the production log closes the loop of evaluation-driven development, and you can go back to the first part, basically build step to further improve your system. So in summary, MLflow 3 helps you in each step of evaluation-driven development with features such as tracing, feedback tracking, the evaluation suite, dataset management. So allows you to iterate on your agent apps first with confidence. And to get started with MLflow 3, you just need to install MLflow 3 from pip using your favorite package managers like Conda, UV. And yeah, then check out the new documentation. We did an overhaul of documentation in response to MLflow 3 release, so please check it out. And we have to say that evaluation feedback features, some of them are not open source yet fully. And we are working hard to open sourcing them in a few months, and you can see the progress in the GitHub level. And yeah, after you try out the MLflow 3, please report bugs or put any feature requests in GitHub. We're monitoring the GitHub issues and pull requests every day. So your contribution is pretty highly appreciated. All right, so this is a quick recap of MLflow 3, and I have another news. So especially for application developers. So yeah, I spoiled it in the title, but yeah, the news is MLflow will support TypeScript natively. So what does that mean? So MLflow with the SDK implemented in TypeScript. So now you can build a full stack app, AI app with the TypeScript SDK with MLflow to get plug in the tracing, evaluation, monitoring super easily with MLflow. And regardless of your project language, whether it's written in Python, written in TypeScript, JavaScript, you can manage them in the same MLflow platform. For example, if you are in the team, ML team, and you have a shared MLflow tracking server, some of your project might use Python to do data science, but some of your projects might use TypeScript to just do a full stack development using the LLMs, like proprietary LLMs. So you don't need to use two different tools to track and monitor those projects, but you can just put everything in the MLflow. And yeah, also you can connect between two languages. For example, your app is written in TypeScript, but you can analyze or evaluate the quality using Python in Notebook by pulling the traces from MLflow, which is pretty great. So in this session, I built a simple chatbot powered by Claude and MSP, and I just injected MLflow TypeScript SDK, which is in development. So to just showcase how it looks like, yeah, and yeah, I will switch the screen to my demo app here. This is pretty simple app, but yeah. So basically, this is a chatbot, and this has like tool access. So under the foot, there's some React agent implemented with Claude API and MSP. So I'm gonna ask a quick question about where is the capital of Japan? This kind of question is asked a lot in the tutorials, so I just go in the same way, and it's just doing some web search. Some of them are mock, so please bear with this if it doesn't return a good answer. And yeah, it seems the answer is correct. It's Tokyo, Japan's capital. So once the agent runs, we can see the traces in MLflow, and this time I'm using the DevRex managed MLflow. So we can see the traces in this screen. And yeah, so in this top row, we have a trace. And all the code execution, all the tool execution LLM query is shown here. And you can see the timeline as well. So there's basically 3 LLM calls made and 2 search web tool execution. And yeah, we can also see what is returned by tool or what is returned by LLMs. And yeah, this is the tracing. And another good thing you can do is, okay, let me go back to the demo app. So as I covered in the previous part, monitoring is pretty important because you need to get actual real user feedback on the query to actually get the true signal of the agent query. So here I just injected the small widget for your users to put thumbs up or thumbs down. So I would put thumbs up here because the answer is correct, and just type a short message here and submit the feedback. All right, so it accepts the feedback. Then we can go back to the traces tab again, and then reroll it. Yes. So now we have a feedback actually annotated on the trace. So you can see the feedback, user feedback here, and you can see the message, like the message I typed there as a relational of the feedback. And you can see the aggregated result here for all the questions I did yesterday. And also you can see the chart here to monitor the app. So we have a latency monitored here. We have request count here. We didn't have errors, so it doesn't show the error count yet. And also you can see the user feedback assessment here. So the red is a bad quality, green is a good quality. So we can check the growth. So all right, going back to the traces view. And yeah, whenever you have a bad quality response, you can go back to the trace and find what actually went wrong in the agent execution. And all of this is done by TypeScript. So you don't have to like use Python to build your app, but instead you can just directly insert MLflow API to like create spans with spans in the TypeScript in your full stack app. So going back to the presentation. Yep. So yeah, so this is a kind of sneak peek of the TypeScript SDK. You can see the branch in the MLflow GitHub repository. I don't cover the code details here, but we are planning to launch the first beta SDK in sometime in July. And yeah, the initial release covers a subset of MLflow features such as tracing or feedback tracking, which I showcased in the demo. So more coverage might be added. I don't guarantee, but yeah, if it's requested by community, we will make it happen. So like from the registry evaluation, those features are pretty useful as well in the full stack app. So we kind of foresee adding those features on top of the SDK. And yeah, for tracking server, we don't implement the tracking server for it with TypeScript. So you can just connect to the Python-based server, or you can use managed service or Docker or Kubernetes to deploy the server separately. Yeah, so stay tuned for the launch. And yeah, we are also yeah, looking forward to all the feedbacks about the SDK once launched. All right, so yeah, this is my part. So I gonna answer a few questions from the chat.
Awesome. Great job, Yuki. Really appreciate that presentation. We do have a few questions here in the chat, so let's get to it. The first one that came through, how should AI engineers think about using human feedback after it's collected? How can the feedback be used to improve agents?
Yeah, that's a great question. So human feedbacks, first of all, yeah, the easiest way to use the feedback is basically inspect your execution and find the root, connecting the root cause. So if the human feedback is like this answer is not factual, you can go to the retriever or true cause result to see. So basically, MLflow allows you to inspect the root cause in detail from that kind of top level human feedback. And also another way is actually, so you get the feedback, but that's the only feedback for that specific answer. So when you improve your agent, when you actually like make change to the agent and run again, you will get a different result. And you can also ask the same person to get feedback again, but it'll take time. It's very like costly. So you can actually fine tune, not fine tuning exactly, but basically tune the LLM judge so that it aligns with the human feedback, and then run that as the automatic evaluation to basically get the proxy metric that mimics that like domain export. In such way, you can use the feedback more effectively. So you can actually scale it out to multiple like result like multiple like evaluation run. So you can iterate quickly, and yeah, so yeah, that's basically what I would do. Yeah.
Excellent. And also, so you showed third-party evaluation systems like Ragus with MLflow scores. Is there a plan to build native integrations with these libraries in the future?
Yeah, that's a great question. So in the first phase, we will probably provide like wrapper references there, just a few lines of code. It's very easy. But if we get the more usage or more interest from the community, we're definitely happy to provide a native integration, like actual API from MLflow or a more close integration about the visualization or yeah. So definitely we're kind of like hearing the community feedback. So if you're interested in it, just please submit a feature request or issues in the GitHub repository.
Perfect. And while we're on the topic of plans, you mentioned that evaluation feedback features will be open source soon. What does that timeline look like, and how can the community track progress or contribute?
Yeah, this is a great question. So for evaluation and feedback, we are planning to open source it in July or August. Um, in the current progress, I kind of hoping to release it in the next minor version, like 3.2, but it depends on the last minute timeline. But yeah, also you can track the progress in the GitHub repository. We just making the PRs, a lot of PRs. And yeah, if you want to contribute, just let us know. You can contact us in the GitHub or in the Slack community Slack. So we can assign some of the small tasks from the some of the work, or maybe in the other features. So definitely just please contact us for your contribution.
Great. And we'll be sure to drop links to the Slack as well as GitHub for you to easily access those channels. Lastly, what best practices would you recommend for capturing and analyzing traces in large-scale production GenAI systems?
Yeah, this is also an awesome question. So yeah, there's not like it's a single bullet said like, yeah, this is a best practice. But if I were the engineer, I would actually consider about the security and the data size a lot in building those kind of monitoring system. So security is pretty important part because traces includes raw input, user input, and traces include internal data like retrieved document. So it's pretty important to maintain the good security and governance when building a monitoring system. You don't want to expose all the data to like public or anyone in everyone in the company. So I would put that requirement first in the designing the monitoring production system. The other side is the data side. So trace is a pretty rich data. It can contain a lot of internal steps, but it means that it comes with the cost of the data side. So you often have like tens or even like hundreds of megabytes of data if you actually do like crazy retrieval steps. So there's a feature incoming in 3.2 that allows you to pruning the trace data before exporting. For example, you can cherry pick which step to log or which input to log or redact like personal info or some specific attribute. So I would design the trace like that's like filtering logic nicely, such that you can only get the useful information from traces, but not logging everything and waste the storage cost. So yeah, I think that's the 2 point I probably care most. There's a lot other few tips like making it non-blocking or also setting up the good results like infrastructure strategy, and also like having a sampling ratio for the monitoring. There's a lot of tips, but I've probably picked those two as a top two practices.
Excellent. Great insight. Thank you so much, Yuki. With that, we will go into our next topic here with Sandeep. Hello, Sandeep. Let us bring over your presentation, which we're going to be diving deep into managed MLflow services within the Sagemaker ecosystem. So let's bring this up. Perfect. We'll turn it over to you, Sandeep. Thank you.
Thanks, Carly, and thanks, Yuki, for the great presentation. Hey, everybody, I'm Sandeep Raveesh. I'm a senior GenAI specialist essay in the SageMaker frameworks team. I specialize in machine learning and GenAI, particularly in operationalizing AI ML workloads. Today I want to talk about uh, I hope I'm sharing the right screen. I want to take this time today to talk about SageMaker and the problem space that we have designed SageMaker, how we solve for AI/ML workloads, and then we'll dive deeper into the fully managed MLflow offering in SageMaker. A quick poll, drop in the comment as a comment in the chat window if you are a user of SageMaker or even AWS. It'll be great to know how many of you are out there. With that, I can get started with the understanding the space in which we work in. there has been significant interest in AI ML, and however, most organizations we have heard face major hurdles and struggle, particularly when taking AI ML workloads from POCs, that is, from the experimentation phase to production. A recent survey found nearly half of the initiatives stall or fail at the POC stage, that is the experimentation stage, and many of these ML pilots are soon abandoned as they fail to deliver return on investment. Despite these high failure rates, enterprises are investing a lot, and the investments are accelerating at unprecedented pace. When we look at the challenges which the customers are struggling, it's largely starts with lack of cross-functional collaboration. As you might know, when we are operationalizing AI ML workloads, it requires multiple teams collaborating, like data science teams, engineering teams, operations, infrastructure, the overall platform team. We have seen with users, the customers struggle with these streams working many times in silos. And also, there is a lot of ineffective tooling lying around. Many customers have data scientists and ML engineers and teams working primarily in Jupyter notebooks. I know many of you can probably relate to this. And lack of these toolings and processes, like from version control, having data and code versions, having a way to reproduce and track experiments and automate the overall training and deployment, creates a lot of friction. And there is also poor data and ML governance. Good quality model, as many of you might know, requires good quality data for training. And many times customers struggle with data in silos. Data is probably owned by the business or the data analytics team. And for the data science team, discovering this data and accessing this data is particularly challenging, dealing to poor quality of data for their use case. And also another common practice which we have seen customers struggle a lot is the overall ML governance, because developing models, deploying the models throughout the life cycle, they require governance, evaluations, tracking, whatnot, and having a good process and good tooling to support that is important. And we see customers struggling with it. And one way to overcome these challenges is, because of the cross-functional nature of the AML space we live in, MLOps is one such holistic way to solve all these problems or to overcome these challenges. And MLOps generally is comprising around automation, standardization, and governance. And to understand MLOps, and particularly how in SageMaker we can realize the end-to-end MLOps lifecycle, let's take a look at how SageMaker approaches it. With SageMaker, as you can see here, we support the different cross-functional teams. One of the challenges we were calling out earlier, where the different personas, be it the business stakeholders to the platform team, which is building the secure platform, or be it the data scientists who are doing their magic of building the GenAI or the model workloads. Um, and SageMaker provides a single unified platform for accessing and performing your entire AI/ML lifecycle, starting from onboarding projects, use cases, having a secure and standardized experimentation environment with SageMaker Studio, build and train your models with efficient compute, CPUs, access to GPUs, whatnot, and having both managed and fully controllable compute options like SageMaker pipelines, more orchestration, more scalable like SageMaker HyperPod, or even the other AWS ecosystem resources like EKS, the Kubernetes-based offering, and ECS. And then having a way to track from the build phase itself out of the box. Of course, this is where SageMaker managed MLflow shines a lot. After the building stage, having a way to register the use case with its model, or if it's GenAI applications, having a way to version so that you can track and govern the developed versions, and from there selecting the appropriate version and then deploying it and monitoring it with SageMaker Model Monitor. Also, we have a partner ecosystem, like you have apps like Comet, Fiddler, which helps provide many other use cases. And so with this you have a full choice of tooling which fits your use case. You can pick and choose. Overall, you'll be also able to scale. Finally, this scaling is done really by having a templatized project so that you can onboard and start new projects, each of this following the same standardized process you have laid out. So this way you can bring multiple projects, multiple AI use cases on board all at the same time. With this understanding of the problem space and some background of SageMaker, let's take a deeper look into the fully managed MLflow offering in SageMaker. Overall, I'm not going to dive into what is MLflow. I think you all are already the experts. Many of you are familiar with it. But overall, MLflow helps you through the entire ML lifecycle, from experiment tracking all the way up to deployments and monitoring. I want to talk more about how you can access and use MLflow efficiently for your use case, but also for your enterprises. And taking a step back, since MLflow is an open source project, for a long time, customers who wanted access to MLflow, particularly at their enterprises, had to self-host or self-manage MLflow. And when you have a self-hosted, self-managed MLflow, there are significant challenges, significant operational challenges. They have to set up MLflow tracking servers, provision compute, database storage, and each of these resources, compute, databases, they all have new patches, version upgrades that need to go in, and all of this needs to be managed by the team. And MLflow itself are coming out with newer versions and upgrades. Some of it are awesome upgrades, but you'll have to then manage it, version it, upgrade it, and find a way to migrate users from between different versions. Creates a lot of complexity. And there's not really a native user access control or fine-grained access control mechanism, which is needed in an enterprise setting. And in an enterprise setting, lack of integrations with other customer tooling becomes a problem. You can train a model, you can track it in MLflow, but then how do you take that forward to deploy it and scale it becomes a problem. And you can, in some ways, overcome some of these shortcomings with a lot of manual efforts and other workarounds, but each of this adds a large layer of complexity, and this leads to overall higher costs, slower pace of innovation, and it can become particularly challenging for customers. This is where enter SageMaker Managed MLflow. It's a fully managed tool which is offered in SageMaker to help you through the entire ML lifecycle. It orchestrates the entire setting up and managing of MLflow for you. So that you can spend your efforts working on your cool AI ML projects and solving core business problems and not worrying about setting up tracking servers and dealing with versions, whatnot. SageMaker fully managed MLflow offers the entire MLflow capabilities for ML and GenAI experimentation. So your data scientists and teams can deploy with click of a button, access and use MLflow for your experiment tracking, evaluation, deployments, all out of the box in AWS SageMaker. Now let's take a look at how it looks. I'm going to switch over to my AWS account, and I have a SageMaker Studio environment open here. You can do that through the console by going to SageMaker AI. And once you land into SageMaker environment, this is the home screen where you see your entire SageMaker Studio environment, you have everything that you'll need in the ML lifecycle, from data, from compute, experiments, which is where MLflow shines, and you have more managed jobs and pipelines for training your models and use cases, and finally registering it and deploying it. Also have Jumpstart, through which you can access the latest GenAI models. We we look when we want to access MLflow, it's part of the application suite where MLflow is offered. It's this deployment of SageMaker Studio can also be controlled by your administrator. So this is giving the governance for an enterprise setting. So you can control how SageMaker Studio looks and feels for your end users. And when we go into the MLflow window, this is where we can see all the fully managed tracking servers. I have a bunch of them created, but to create, if you want to let users create it, it's quick, easy. Click on the create button, and it comes auto-populated with any defaults which your administrator has set. So this is very easy to set up. Just to give you some background, there's an IAM role that's associated with it. This is how you can bring extra layer of security with fine-grained access control who accesses, who doesn't, and it's all backed by highly available S3 or S3 bucket storage. So rest assured, all your data is backed and supported. And to access the tracking server, all you do is go click on Open MLflow, and it creates the MLflow UI for you. Here I have the one which we are looking at open. It's created using pre-signed URL, so it's fully secure. And you drop into your MLflow UI, a very familiar UI for most of you here. It's the same open source MLflow, which is hosted for you in a fully secure managed environment. So you can do everything that used to do in the MLflow here in SageMaker managed MLflow. Here I have a couple of experiments that I have run, for some with GenAI use cases, like with agents, with land graph, evaluations with ragas, and also using some of the latest agentic frameworks like 𝗬𝗏𝗃 SDK, the AWS open source SDK, and I can experiment and use it. This is showing and highlighting how easy it is to integrate and use the other aspects, other tools, other APIs that are there in the AWS ecosystem. So you don't have to do additional configurations to get access to it. And just to show you how this looks, this is an experiment for a land graph based agent. And I have a bunch of experiments that I've run where I've done evaluations, all using LLM evaluations, be it ragas or be it MLflow's own evaluation metrics. And you can see here, you can see the very specific GenAI model that I have used here. This is the Bedrock-based Claude model that is being used. It's all used with quick access API because these models are enabled in this AWS account. So easy to use and access latest models. You can also access models within SageMaker. Let's say you're fine-tuning a model for better accuracy and deploying it on SageMaker endpoint. You can quickly access it directly for your GenAI use case, and you can track it once you start the evaluation and the testing here. And the artifact, all the artifacts which are generated in the experimentation phase are all available. You can access it. They're all also backed in the S3, which is being created with this MLflow tracking server. And you can also access this artifacts directly through S3. So if it's a large data, you can quickly access it using APIs with S3. It's another convenient way. Going back to the use case where you want to train your model from scratch, here's an example I have of training a model from scratch using SageMaker pipelines, which is a fully managed, easy to use training compute infrastructure, which is provided out of the box. And it's easy to configure with MLflow and start tracking it. So here you have all the typical steps that you would see: data prep, training, evaluation, and then registration. Evaluation, whatever metrics that I have used in that training compute, SageMaker MLflow, I have it all captured here. And the model metrics, how you would see typically in MLflow, is available. And then the artifacts in the same S3 location. And I want to show you quickly about the model registration. This is one of the good integrations that help you move fast. Once your model is trained and registered in MLflow, you can automatically have it registered in SageMaker model registry. And here's this model registry, and the run which I just showed you there in MLflow, the model which got created automatically is registered here in SageMaker model registry. So you can have the model registry as a way to govern and control its approval process. And this is also how you can go from taking this model, taking this artifact which is approved, to deploying it. You can take the model from here and deploy it with click of a button and have it being serving traffic within a few minutes. And going back, just to show you how overall where SageMaker managed MLflow plugs into the picture. So we can train, you can track your workloads from notebooks, local IDEs, to anything in the SageMaker ecosystem. We saw an example with SageMaker pipelines, or anywhere in the AWS ecosystem. If it's EKS, the Kubernetes-based offering, EC2, the instances, or any other AWS infrastructure. And you can do everything that MLflow offers, from tracking, evaluation, and model registration. And we can register the model automatically in SageMaker model registry, allowing you a quickest path for inference. Or you can also take the model from there and register it elsewhere, and showing the neat, easy integration with the overall AWS ecosystem. Now, taking this to help you with the overall MLOps and how you can efficiently deploy your GenAI use cases, here's then high level workflow in SageMaker MLflow, how it actually looks. You have users who work in SageMaker Studio. We have notebooks then and there, a secure environment to experiment, and you can automate the workload using SageMaker pipelines. And then you can all track that with SageMaker MLflow then right there. And you can register the model, and you can deploy the model to your choice of endpoints or hosting infrastructure. And you can automate this and scale it with neat integrations to the CI/CD tooling of your choice. It can be GitHub, it can be GitLab, it can be Jenkins. You can integrate with all of those. And this is how you can scale and have additional governance and deploy to different environments, deploy different use cases, and go all the way up to production environments. And just to show you, since we are in the GenAI space nowadays, a very similar view, in fact, is used for the GenAI ops, that is operating GenAI use cases. As you can see here, this is a very similar pattern and workflow that we saw earlier. And this is for fine-tuning a large language model. You can access large language models from Jumpstart, which is the SageMaker owns own repository of GenAI models, but also you can bring GenAI models from elsewhere, like Hugging Face. You can do the fine tuning all within the SageMaker ecosystem. You can use more scalable compute like Hyperpod, which is the Kubernetes-based orchestration. So you can scale and use larger GPU instances and train your models. You can track with MLflow, and you can track the experimentation. Of course, with GenAI use cases, you have additional considerations with LLM evaluations, prompt catalog, and AI gateway. All of that you have with the different toolings that are available in the AWS ecosystem. And using this SageMaker MLflow pattern with MLflow, we have customers who have successfully enabled their ML workloads. Here's one such customer story where they are facing a lot of challenges, particularly like scaling their ML projects, long startup times, unexpected costs, lengthy time to market. And using these SageMaker MLOps patterns and tools, they were able to overcome many of these challenges, resulting in reduced onboarding times for their teams from over a month to less than a day, and reduced time for model to production, anywhere from 6 months to just a couple of weeks, and accelerated time to value by almost 4x with faster delivery of end-to-end solutions, thus improving the overall return on investments. Thank you. If you want to learn more, grab the links here through this QR codes. You have solution sample codes, you have end-to-end workshops, and these end-to-end workshops come with free AWS accounts, pre-configured everything you need for a workshop to run, so you can learn quickly. Reach out to your AWS account teams and partners to get access to these workloads, to workshops, or need additional help. Of course, you can reach out to me. I'm on LinkedIn. Thank you.
Awesome. We'll leave this screen up for just a bit so everyone is able to scan here. But thank you so much, Sandeep, and let's dive into questions here.
All right.
Okay. First one. Let me put you. In SageMaker's managed MLflow integration, are you using the open source MLflow registry proxy server behind the scenes, or do you have your own implementation that pushes artifacts directly to S3 buckets?
That's a great question. I think some of this is internal operations and it's confidential. I cannot disclose that, but we do have our, from what I have experienced using it, we do have our own implementations to make it work easy and conveniently with MLflow. So generally, my experience and also the customers that I've talked to who use SageMaker and MLflow at scale have no issues with MLflow in SageMaker, and particularly having the artifacts being backed in S3 or accessing through S3. In fact, they have built patterns through which they use these artifacts in S3 to scale and do all the complicated deployments that the large enterprise settings customers might do.
Fabulous. Going into another one here, how does SageMaker's managed MLflow support tracking experiments across different environments, local, SageMaker Studio, pipelines, etc.?
Yeah, I would look at tracking with MLflow very similar to how you would use it when you were using it with the open source MLflow. Where you point your experimentation to the MLflow tracking server that of your choice, and that's about it. It under the hood uses the same MLflow SDKs and libraries, and it points all the experiment tracking information to that very specific tracking server that you want, and you can use the same patterns that you used in the open source for managing and organizing your experiments in MLflow. The same patterns work with SageMaker managed MLflow.
Great. We have a few more here that I think we're able to get to. At what stage or scale of an ML project would you recommend moving from self-hosted MLflow to SageMaker managed MLflow?
I love that question because it's the most easiest answer. I would say do it ASAP. get on it ASAP, because it's really when your data scientists and I'll start working on use cases, you kickstart a tracking server. Many times you start building assets on top of it, and it becomes soon difficult to move away from it because you have put so much effort and your assets are already there. If you move away, go to a new environment, you'll have to move everything. There might be complicated workflows that you figured out overnight, maybe, and you'll have to try to figure out how all of this runs again in a different environment. So my best advice or guidance would be, as soon as you start using, and right in the beginning phase of your project, get started with SageMaker managed MLflow. And as I showed you, you can get started very quick with click of a button. It's a fully managed, it gets spins up with the default values for you. So it's easy to spin up and use it in your project.
Great. Two more questions. Are there any differences in how experiments and runs are logged or visualized in SageMaker's managed MLflow compared to self-hosted MLflow setup?
Not really, I would say. I think once you go into the MLflow UI, it's really the same open source version, which is hosted in SageMaker. So I wouldn't see much difference from a visualization perspective.
Awesome. Our last question here. Looking ahead, what upcoming features or enhancements can users expect for managed MLflow in SageMaker?
Yeah, we have plenty of features coming out. Of course, roadmap information is a little bit confidential. I can't necessarily talk about it, but we do have enhancements coming from how these managed MLflow tracking servers are deployed and how they scale. And then we have enhancements coming from how they are integrated with the overall AWS ecosystem, so that you can access not just for ML use case, but also for some of the newer GenAI use cases that are coming out these days. I would say follow our channels, particularly around big launches around the AWS events. I think recently we are gonna have the New York City Summit. There should be launches there, and if you're following the channels there, you will get hold of the latest information. Of course, you can reach out to me. I'm on LinkedIn, and if you have any questions, I can help answer there.
Awesome. We'll be sure to tag you in the LinkedIn comments so people can find you easily after
Thank you.
this. Of course.
Perfect.
Okay, that rounds out our live Q&A, and we're just a few minutes past, so perfect time to thank everyone for joining us for today's MLflow Community Meetup. It's been awesome, great discussion, and awesome to connect with everyone. Big shout out to Yuki and Sandeep for leading today's presentations. If you'd like to continue the conversation, please join MLflow on Slack. You can chat with other community members and get support. We encourage you to get involved, whether it's through contributing code, joining discussions, or attending future events. In fact, our next MLflow community office hours is scheduled for July 9th. We hope you can join us. Thanks again for being part of the MLflow community, and we look forward to seeing you.